My name is Mark, and today I'm going to be talking to you about the Unity 5 game engine. Now, the term game engine gets thrown around a lot. Does anyone know or want to take a shot at what a game engine actually is? Anyone? Just shout random things out.
Physics.
Yeah, physics. Yeah, that's one component. Very good. Yeah, how about another one? Sure. Yeah. All these things. Yeah. Sure, definitely. Yeah, so like a game engine basically has a lot of different components to it. And sometimes these subcomponents are like referred to as engines themselves, like you said, like a physics engine, or like a rendering engine, or like with game states, you have like scripting and like pathfinding and stuff like that. So basically a game engine is like a collection of a lot of different components that handle specialized things. So Unity 5 is basically the latest release of the Unity game engine. And it includes like a full like 2D and 3D rendering engine, and like also includes physics, which is a physics engine, like you mentioned. And it has like basically two different flavors. There's like a free version and a professional version. And the good thing is the free version actually has all the features that you would need to make a game. And I'll go through the distinction between the two versions a little bit later. But so like another thing you might ask yourself is, how can I actually use it? Like, you know, we're learning JavaScript over here. Is this something that I can use? And it turns out, yeah. Like Unity 5 was mainly aimed at like consoles and like PC and Mac. But it's actually expanded a lot now, and it's available on like 15 different platforms. And you could even like write JavaScript games in the browser using WebGL. So all of us can start playing with this today. And that's the goal of my presentation here. Hopefully I'll like pique your interest. There's a lot of stuff to go into, so I won't be able to go into all of it, but hopefully I'll get you interested. So the first component I'm going to talk about is like graphics. And this is an example of some of the kind of graphics that you can achieve with Unity. I don't know if you can get this in like the browser with JavaScript. It might be a little slow, but this is like something you might see on consoles or something. And you can notice like basically like the ground and the textures kind of like reflect light and all this kind of stuff. And I'll talk about how that's like actually accomplished. So basically in the game world, you have like a 3D wire mesh. And it's covered with these things that are called shaders. Now what a shader basically is that it's just like a lot of different texture maps overlaid over each other. And they can create like tons of different effects. Like you can basically like create any kind of material that you want just using the right shaders. And like the two main ways of defining a shader is either like specular or metallic. They're basically the same way, the same thing, but specular kind of like you can change the color of the reflection in the material, whereas metallic will just reflect the color of light that's hitting it. And you can see like from the left to right is the value of the specular property or the metallic property turned all the way up. So something very metallic will reflect a lot more light. Something not metallic will reflect no light. And the same thing for specular. Now, the different kind of texture maps you could put into a shader are things like normal maps, height maps, occlusion maps, and emission maps. And a normal map basically controls like how bumpy a surface looks. So like on the image on the right, you can see like this is just a plain texture without a texture map. It just looks very flat. But once you put like a normal map on it, you can kind of see like more like roughness in the texture. So it makes it look more lifelike. And then so the other kind of maps are like occlusion maps, which you can use to like make a part of the texture not react to the lighting in the scene. And then you have like emission maps, which will make a texture give off light. And then there are a bunch of different ways to like define lighting. You have like a point light, which will shine light in every direction. You'll have like a spotlight, which will just like make a cone. And then you'll have like a surface light, which is kind of like a point light, but instead of being a point, it's just a flat surface. And then directional is kind of like a surface light, but instead of going all directions, it goes just in one direction. So that's kind of a brief overview of like graphics. Now I'll talk about like how physics is like handled in the Unity 5 engine. And basically there are like three components to like defining how physics is going to work in the game engine. Like first you need to define like your like object. So you need to, if you wanted to like actually interact with gravity or like be affected by gravity, you would have to first like give it a property like it's called a rigid body. So then at this point, like it'll be able to like collide with other objects or like be influenced by gravity. And the way that collisions are handled is that like you have to like define, like the same way you would define a wire mesh to like show how an object looks, you also have to define like a wire mesh to show like the boundaries of an object. So like where it's going to hit, like if it's going to hit on the edge, a little bit outside, or if it's not going to hit at all. And then another thing that you need to like define how physics works in a game engine is like scripts. So like for example, if two objects collide, you can then give it the option to like execute a script to like make a sound happen or like make an event happen. So like if a plane crashes, maybe you want to have like a cutscene happen at that point. So you would do that with a script that would like trigger after like a physics collision. And then another important thing is joints. So basically a joint is like the way you connect two different physical objects, and it like kind of like defines the degrees of freedom. So like for example, like your elbow is kind of like a hinge. So that's like the way you would want to like define like that kind of rotation. And like you can also have things like springs which will like expand or contract. Okay. Now another important aspect is like scripting, and this controls like how like events and interactions happen in the world. And there are three kind of main like script categories. There's like initialization script, where like when the world like loads up, like everything kind of gets like a behavior to like define how it's going to act. And then you also have like an awake script when you actually walk into that part of the world where you can actually come into the object, come into contact with the object. That script will take over. And then you also have scripts associated with like the GUI and physics, and the GUI scripts kind of reminded me of like a browser, like you know how like you have like hover and like mouse click actions. So the corresponding ones would be like mouse over and mouse down, and then you also have scripts that happen like during physics reactions, like when I mentioned in the previous slide, like when two things collide or when they break apart. So another important aspect is like pathfinding, like how do things find their way around the world? So pathfinding is when you actually like define that. So when you build the world, what happens is like something called a nav mesh gets created, and that basically shows like all the walkable areas of the world. So basically, if something doesn't have a nav mesh, like you can't walk over it or you can't access it. And this is automatically created when you make your level. And then you have things like nav mesh agents, which are like for non-player characters. So like if you're like you have guards at a base, they're not going to walk into each other, obviously. So that's how you would achieve that in Unity. And then you also have things like nav mesh obstacles, which is like if you have something that's like swinging or like a boulder falls off a mountain or something, initially like the ground is going to be walkable, but when that boulder falls down, it's not going to be walkable anymore. So it actually deletes the part of the nav mesh. So now characters know they can't get there. And then you also have things like off mesh link, which is where like NPCs can like jump over things or like open a door, so then they'll know that they can access other parts. So those were just a couple of components. There's really a lot of components to a game engine, and I couldn't go into all of them. So some of the other ones were like animation, networking, user interface, and also like a level editor to like actually be able to create all this kind of stuff. So now I'm going to talk about all the different platforms that are supported by Unity. And basically, like there's Mac, there's even support for Oculus, so you can make like 3D games now, which is pretty cool. And then there's iOS and Android. It's also the default software development kit for the Wii U, which I found pretty interesting. I didn't know that. And you can even make native apps for the Samsung TV, which is I found kind of cool. And then some of the other things you get with like the Pro version is like you get Cloud Build, which is a tool which is once you upload your code to your like version control system, it automatically builds your code for you and kind of sends you a link to your executable or whatever, so that takes like a lot of resources off your development team. And then you also get like priority support and like a lot of statistics and stuff. And okay, so like the way you can use it yourself is through the library WebGL. So WebGL is like a library for making 3D graphics in the browser, but it's really, really hard to use. Like, if you wanted just to make like a basic shape, it would be like 400 lines of code. So there are like libraries on top of it that you can use to do that kind of stuff. And some of them are like Three.js, the Unreal Engine 4, and also Unity. And then the browsers that WebGL supports is Chrome, Firefox, Safari, and Opera. And that's it. If anyone wants to look at more info, I have some links over here. And then I just wanted to show you an example of a game that was made with Unity, so you can see like what you can do with it. And you can see you can really get like some lifelike graphics and kind of like interactions with like the wind and the trees and all that kind of stuff. So it's pretty cool. And if you just want to see what you can do with the JavaScript version, this is like a game. So you can see it's not as sharp, but you can still do a lot of stuff with it. So I hope I kind of piqued your interest in it, and maybe you want to check it out. And that's about it. Thank you very much.